Nerds, welcome back. Today we're going to be working through climate. So you should have just finished your weather and meteorology and storms. Okay, so we're still technically in the atmosphere kind of area of study, but we're transitioning from atmosphere into biosphere because we're going to do climate um, now. This week we're doing climate next, and then we are going to be doing um, environment stuff next. After environment, we are going to be environment's pretty quick. We can wrap that up really quickly. After that, we're going to be moving into astronomy, and then we should be done. So let's go ahead and get started with climate for today. Okay, so climate. Now, the way that it differs is that it is different from weather. Climate is the long-term weather pattern for an area. Okay, this describes annual variations in temperature, precipitation, wind, other weather variables. Okay, so I think we've talked about this before in a different lecture, but an example of the difference between climate and weather is that, the climate in Florida is generally warm with a lot of rain, warm and wet. But sometimes it snows in Florida. Okay, sometimes the weather, the single days, the at that time is cold and dry, but most of the time the trend is warm and wet. Okay, now climatology, like meteorology being the study of weather, climatology is the study of Earth's climate and the factors that affect past, present, and future climatic changes. Okay, so it's not just what is the climate, but what are the factors that go into it and how are they changing. Okay, so let's get some vocab. So normals first. So a normal is the average meteorological records for the past 30 years. Okay, the reason that we use 30 years is that is a very long and relatively consistent time frame, so that we can actually see are there trends upwards, trends downwards, is everything staying the same? We really like to see what is the normal. Okay, and this records, as you can see, daily high and low temperatures, daily rainfall, daily wind speed and direction, daily humidity, and daily air pressure. Okay, so and the main reason that we have these normals is so that we can compare day by day by day, what does it look like based on the normal. Okay, so climate, what causes climate? Okay, why do we see different climates in different places? So first, one of the main things is latitude. The further north or south of the equator you get, the cooler it gets, because areas at or near the equator receive the most direct sunlight, right? And we knew this. This is not super new information, but this area in the tropics and at the equator is getting the most sunlight year round. More sun you get, more energy you get, more temperature increase, okay? Because that energy gets transferred as heat. Whereas near the poles especially, you're getting very little sunlight in certain times of the year versus a relative amount in other times of the year, but most of the time you're not getting nearly as much, and it's usually more filtered, so you're not going to have, less sunlight means less energy, means less heat, so it's cooler. So the higher the latitude, lower the temperatures. Okay, cooler, 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 warmer, 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 warmer. Okay. So we've got three main areas. We've got the tropics. This is between the 23.5 degree mark, north and south, to the equator. So these are the tropics, the north and south tropics. Notice they are places that you would think are generally tropical, tropical or warm all the time. So Central and South America are mostly in the tropics. If we were to rotate that globe, the other place would be most of Africa, okay, and the Middle East. The temperate zones, this is going to be 23.5 to 66.5 degrees north and south. Okay, now these are the areas that generally we live in. So most of North America is in a temperate zone. Most of Europe is in a temperate zone. Okay, pretty much all of Russia is in a temperate zone. Okay, meaning that you get changes during the seasons. And then you got the polar zones at 66.5 degrees up to the poles. Okay, up here, it's usually going to be very cold. Okay, very, very cold, not getting nearly as much sun. Okay, so these temperate zones are kind of interesting because they, unlike the tropics, which are warm most of the time, unlike the poles, which are cold most of the time, temperate zones are temperate. They're kind of in between those two extremes, and they change. They're seasonal. So fall, or rather winter versus summer, is going to be very different temperature-wise, unlike on the equator, where summer versus winter is pretty similar in many ways. Okay. So, what causes climate? What else besides latitude? Topographic effects, okay? Land masses, how the land is shaped. So, water heats up and cools down more slowly than land does, okay? So, coastal areas are going to be more moderate than inland areas. That's why the beach is usually more moderate in general than any place inland. So, if you go to the beach in the winter, it is going to be generally warmer than if you went to, or if you stayed inland and stayed in the main part of the continent. If you went to the beach in the summer, that's why people like going to the beach so much. Number one, because there's water, but number two, because it is generally cooler than it would be inland. Okay. We also see differences in elevation. So as elevation increases, temperature decreases. This is mainly because the air is thinner the higher you go. So the higher you go, the less heat is retained by the air around you, and so it gets colder. Okay. And then this also, we talked about this briefly, I think, in the last video lecture, but on the windward side, you get an uprising of air and a lot of cloud formation and precipitation. On the other side, it's going to be quite dry. Also depends on really the formation, because you can say that sometimes on, the opposite. And then air masses, as we've talked about before. So the reason that the southern United States versus the northern United States have such differences in temperature, number one, is because of latitude, but number two, because the northern United States is going to have a lot more polar air masses, or Arctic air masses even, that are coming in and making that area colder, whereas the southern United States, southern North America, is going to be having a lot more tropical air masses that are going to be coming up from down south, making it a bit warmer. Okay, and when those come together right here in the middle, that's where you see a lot of rain and a lot of storms. Okay, so there's something in certain areas and in certain locations, are things called microclimates. I realize I'm blocking. Microclimates, these are localized climate that differ from the main regional climate of the area. So a hill/mountain, you're going to have a bit of a microclimate, because on one side, the sun hits the entire hill, the entire slope is a lot of sun, so there's a lot of trees, it's relatively warm, where on the other side it's shaded, which means that it's cooler, and it means that you might be getting more precipitation on this side. Just kind of depends on the topography. But so you're getting a slightly different climate on either of these sides. Okay, bodies of water. Great example, slope or side of a house that facing the sun or away from the sun. Or this one, which is very, very interesting to me. Okay, heat islands. So a heat island is a particularly man-made thing. This happens in cities. The presence of many concrete buildings and asphalt causes a warmer climate in city and urban centers than in the surrounding rural areas. So Washington, D.C. and the surrounding area, you can see right here, these are isotherms. So these are lines of temperatures, okay? So what you should see here is that right here in the city center, as you move out, each of these lines is a change of what looks like 0.5 to 0.6 degrees, I'm assuming, degrees Celsius. Okay, so right here in the city center versus out here in the country, there's a difference of almost 4 degrees Celsius. Now, it doesn't sound like a lot, but if you convert that to Fahrenheit, that's somewhere closer to between 8 and 10 degrees Fahrenheit. So while it might be 80 in the middle of the city, it's like 70 out in the country. The reason for this is because generally with plants and dirt and stuff like that, a lot of light and energy gets absorbed and or reflected, and so the heat doesn't really get trapped as much. Whereas in a city where there's a lot of glass, metal, concrete, asphalt, okay, all of these things are either going to be reflecting or fully absorbing the energy. Asphalt is black, it's going to be absorbing all of the energy and converting it to heat. Metal and glass are going to be reflecting all of that light back around and kind of in a circle, and that can cause heat to kind of get trapped, energy to get trapped. So it's going to be much warmer. So the middle of Manhattan is going to be significantly warmer than somewhere out further away from New York. Okay. Now, climate change is something that we are going to talk about, but first we're going to talk about like natural climate changes. Okay, some long-term changes. So ice ages are natural changes. Okay, these are periods of extensive glacial coverage producing long-term climatic changes. It's funny because people think ice ages were things where the entire world was covered by ice, and that's just not. It's not really accurate. It's not really true. Ice ages is much more what happened. It is times when the glacial coverage up north goes way further south than it is now. So, for example, we have no glaciers in the United States, as far as I'm aware, or very few. But during an ice age, the glaciers would be pushing down into the Midwest. So half of Indiana, Illinois would be covered in ice, and that's very different. Now, that does affect the entirety of the world. The reason that happens is because the global temperature is much lower. That doesn't mean that the world is covered in ice. If that was true, then I don't think anything would be alive. Okay. We also have things that are climate changes, but it's kind of funny. They're a little bit more weather related. So there are two things called El Nino and La Nina. Okay. These are kind of seasonal, cyclical, kind of cycle changes that happen year to year to year. So El Nino happens when warm water off the coast of South America. When we have warm water off the coast of South America. Storms are in normally dry areas, drought in areas that are normally wet, fewer hurricanes in the Atlantic Ocean. Okay, so what you see here is this is Australia into South America. So this area is much warmer versus these areas which are cooler than normal. Versus La Nina, colder water off the coast of South America. Okay, that actually means that things are a little bit more stable, and it's not quite as turbulent. Okay, you're not going to get as many storms. Okay, we also have some other natural changes. Solar activity. Sunspot cycles can cause warmer and cooler temperatures on Earth. Okay, so if we see here, so the blue line down here is the sunspot number, which we didn't start recording until the mid-1700s. Okay. And then the red line is severity of winters in London and Paris. So not too bad, bad, pretty warm, really cold. And then if you'll see, the sunspot numbers started increasing a bit. Now you notice that they go up and down and up and down and up and down. That's probably seasonal related, like as the Earth orbits the sun. But you'll see that as the sunspot numbers have gone up, the winters have leveled out. We also have Earth's orbit. So the Earth's orbit goes from circular to elliptical over a course of 100,000 years. Okay. Normally, like what we are in right now, we're in an elliptical orbit, which means that at certain times of the year, the Earth is closer to the sun. At certain times of the year, the Earth is farther from the sun. Funny enough, for us right now, in North America, when the Earth is close to the sun is when it is winter for us, just because of where the Earth is facing at that time. But the Earth's orbit can affect the overall climate of the globe. Okay. We also see a couple other things, some astronomical things. So Earth's wobble. So over a period of 26,000 years, Earth kind of wobbles as it rotates. It's not this perfect rotation. It's not this perfect spin as it goes around. It's also kind of going, whoa, it's kind of spinning around like that, as you can see here. Okay, and that will eventually lead to a reversing of the Earth's seasons. So every 26,000 years, so 26,000 years from now, what we experience in North America as winter would be summer. It would switch. Okay. All right. And major volcanic activity. Large amounts of ash can get caught in the atmosphere. That can block the sun and cause much cooler conditions than normal. This would really only be a big problem if we had a supervolcano erupt. Okay. So a couple other things. The greenhouse effect. Now, there are going to be some required videos on this in the Canvas module, so please make sure you watch them because they're very good. The greenhouse effect is a wonderful thing that happens on Earth. It's the natural heating of Earth's surface by certain atmospheric gases, helps keep the Earth warm enough to sustain life. This is entirely necessary. The greenhouse effect is a fantastic thing for Earth and for the survival of the creatures on Earth. Basically, what happens is that light comes in to Earth's atmosphere, hits the surface. Some of it gets reflected back, up, out, and towards space. But then gases in the atmosphere actually reflect a lot of the heat back down in order to keep us warm. Well, not in order to, and that keeps us warm, whereas some of it then does escape. And this is exactly like a greenhouse, where the light can pass through the window panes, but the heat, once it transfers, gets trapped because of the thickness of the glass. Okay. Okay. Now, the reason that the greenhouse effect can be a problem is because if it is too strong, then we start to see global climate change, okay, or potentially global warming, because the balance of gases is vital to regulating the Earth's temperature, particularly CO2. Okay, carbon dioxide is very important. Too much of it, you're going to have really thick panes of glass that keep all the heat in. Not enough of it, they're going to be too thin and more heat's going to escape. You need to keep a nice balance. Okay, so if we add to the amount of greenhouse gases, that causes the overall average temperature of Earth to rise because more heat is getting trapped. And if we increase the greenhouse effect too much, it could lead to temperatures in excess of what we could survive. Okay, which is not going to be good. Now, global warming versus the greenhouse effect, it is different. Global warming is just any rise in global temperatures. In this case, when we talk about it, it's due to increases in atmospheric CO2. Okay, and this is caused by a number of things. Deforestation, that takes away trees that can, clean the CO2 and turn it into oxygen. Burning excessive fossil fuels releases a lot of CO2 as a waste product. Okay, so you can see the temperatures from 1999 to 2008. It was about 10 years ago. Okay. Okay. So, and this graph here just shows that global warming, a rise in greenhouse gases leads to a rise in absorption of radiation or heat, which leads to a rise in global temperatures. So the mean air temperature for the past 200 years has been slowly but steadily rising. Okay, here's really the graph that cinches it. All right, this is carbon dioxide concentration in the atmosphere. It has been going up, and especially since right around the right here in the 20th century onwards, it's just been boop, 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 boop. It's really quickly climbing, and that's it. Okay, so this is a bit of a longer video, but there was no way I was going to break it into two. Okay, so make sure that you are following your Canvas modules. Make sure that you're doing the things that you need to do. Make sure you're keeping up. If you have questions or if you have concerns, please make sure you're contacting your teachers. Okay, stay safe out there, friends. Stay clean, stay healthy, stay curious. Gucci.